But for negative x values, it's going to be, first, we're taking the absolute value of it, and so it's going to behave precisely like the corresponding positive x value would behave. In other words, this transformation sort of deletes the left-hand side of the old graph and replaces it with a mirror image of the right-hand side. So for any x value now, it's going to be doing what the right-hand side is doing. So this sort of produces automatically an even graph. Okay, and after all that, I can tell you what the problem is asking for is the integral from -1 to 2. And so now I can say, all right, well, I'm doing that and that and that. And what is all that area? Well, this counts, this is -1/4, and another -1/4, and a +1/4. And so the answer to this problem is, -1/4. Okay, 4 more to go. Okay. I guess I'll leave that up still. Really want this to be just one video. I think I've already failed. Yeah, already failed. So this is like part 4 or something. Oh man. 17. What is the integral from 0 to 2 of x over 2 cubed? Alright, I think this is maybe the most interesting problem on this entire worksheet. I think if you are too casual and just try to use like common sense or whatever, you might be wrong here. And so this is a good opportunity, if you're right, to confirm your common sense, and if you're wrong, to get some new, better common sense. Using only this fact above, I am now being asked to compute this new integral. Okay, well, note that we're going from 0 to 2 instead of 0 to 1, but also, what is the x over 2 cubed function? Well, once again from pre-calc A, we explored and learned that if you divide the input of a function by 2, then it sort of stretches the function out by a factor of 2. And so now, what we have is a new function, which, okay, when I plug in 0, it's still 0, but when I plug in 2 into this function, I now get back 1. And so what's happened is this whole function has been stretched horizontally by a factor of 2. And now the question is, what is this area under this curve here? Okay, and I think if you don't think about it too much, or you think about it sort of incorrectly, or you're too hasty or something, you might think, oh, well, this has sort of been balanced out, right? That we've stretched out by a factor of 2, but also we're integrating from 0 to 2, so maybe it's just the same, and it's just 1/4. Okay, but of course that's just not true, right? What is this 1/4 fundamentally telling me? This 1/4 is fundamentally telling me that this shape takes up 1/4 of its enclosing box, 1/4 of this unit square. And so this shape is still the same shape, but it's been dilated horizontally by a factor of 2. And so now the enclosing box is twice as big. It's a 2x1 box instead of a 1x1 box. And the answer is still 1/4, but it's 1/4 of this box. And so the answer is 1/2. We did something like this in the previous video, and the way I convinced skeptics that this was true is by considering the individual subintervals. This is the way to sort of enlightenment here, right? So I want to split this up into many, many subintervals, go to the ith subinterval, and consider this rectangle. What is the height of this rectangle on the ith subinterval? Well, it's just whatever it is. But if I used n subintervals here, then the width, the delta x here is 1/n. But if I consider the ith subinterval of this separate integral, well, now the ith subinterval is going to, when you plug in the input, produce the same height rectangle. So the height is going to be the same, but now what is delta x if I'm using n subintervals? It's 2/n. And so if you divide this picture up into n subintervals, this function up into n subintervals, and this function up into n subintervals, then on a subinterval by subinterval basis, they will be corresponding rectangles with the same heights, but all these rectangles will be twice as wide, and so we'll have twice the area. And since that's true for every subinterval, when you add them all up, you would hope that the area would be twice as much. Okay, good. The last three are just three more. 18 says, what's the integral from -8 to 8 of x cubed? Well, this problem seems to fall outside of our interval that we know about, because we only know what's going on between 0 and 1, but this is just a trick, right? This is just 0. Because regardless of what this function looks like on the interval from -8 to 8, it's going to be, you know, quite huge. This function is odd, and so the interval of any odd function on a symmetric interval around 0 is going to be 0. Okay, last two. 19 says, what is the interval from 0 to 1 of x cubed minus 1? Oh, that's it. Okay, so this doesn't seem too hard. Let's do it. I graph now the x cubed minus 1 function. So it's going to sort of move everything down 1. Yeah. And so it's going to go now like this. I guess. Yep. So that's what this function looks like now. And thus the area I need to find is this one. This red area here. And what is this red area? Well, we sort of did something like this already, right? It is the complement of this shape, which I know something about. And this blue is 1/4, because that's my shape, man. And so this red must be the rest. And so the answer to this problem is -3/4. Another way to do this is just to split this up into two. Then you're not using visual thinking as much. You're just saying, oh, this integral is 1/4 because they just told me, and this integral is just the -1 constant function. Well, that's just -1, so it's a fourth minus 1. That's maybe easier, but I think you learn less if you do it that way. Last problem, and then this is the last video for the week. Integral from 0 to 1 of cube root x. All right. Well, this came up in another video where we tried to find the integral from 0 to 1 of square root of x, and, well, okay, I'll just do it. What does the cube root x look like? I seemingly don't have enough information for this, but since the cube root x function is just the inverse of the cube function, then though I am being tasked to find this area, I once again see that it's just the complement within this box of the area I do already know. So this blue is 1/4, and so this red is 3/4. And so the answer to this problem is 3/4. Okay, I hope you watched this video in 2 times speed. Good job, everyone. Goodbye.